All right, so we are going to start looking at Chapter 7. Okay, Chapter 7 starts out with inverse trig. So we've done a little bit with inverse trig. We're going to look more at the graphs of inverse trig. Bless you.
Thank you.
We're going to look at domain, range of inverse trig. And tomorrow we're going to do a little bit more with, if you're given an equation with inverse trig, how can you get rid of it? Okay, get rid of inverse trig completely. But that'll probably be tomorrow. So remember that any inverse function, not just inverse trig, but any inverse, is basically a reflection over the line y equals x. That's what an inverse function looks like. So kind of as an example, let's do a square root. And what function is the inverse of square root? Yeah?
Squaring.
Squaring. And specifically, squaring when x is greater than 0, because I can't do less than 0 with square roots. So let me just put in x greater than 0. All right, and let me do zoom. Actually, let me put in a line y equals x and do zoom 6. So I'm going to have a squaring function, a parabola, and then I have the line y equals x. It might be a little hard to tell, but I take that. If you were to fold that right on the black line, the red graph and the blue graph would land right on top of each other, because they are inverse functions. Okay? So any inverse functions are reflections over y equals x. Now, for a function to even have an inverse, it has to pass not the vertical line test, but the horizontal line test. Okay, so what the horizontal line test says is if you have a function and it passes the horizontal line test, then its inverse is also a function. So think about the parabola. This is why I only graph when x is greater than 0. If you look at the graph in red, and remember, this part shouldn't be here, just the way the calculator does it. So just ignore that. If you look at the graph in red, does it pass the horizontal line test?
Yes.
Yeah. If I had drawn the whole parabola, would that pass the horizontal line test?
No.
No, it would fail it, because a horizontal line could hit the graph twice. And that would mean that x squared doesn't have an inverse. Okay? For something to have an inverse, it has to pass the horizontal line test. So let's think about sine. Okay, here's the graph of sine. Does that pass the horizontal line test?
No.
No. So that's a problem. If it doesn't pass the horizontal line test, then that means it would not have an inverse that's a function. Okay, we need to work with functions. If we work with things that aren't functions, it's not going to work. So we can make this pass the horizontal line test, kind of like I made the parabola pass the horizontal line test. Instead of looking at the whole thing, we're going to focus on just like a window. So remember, this is 0, 0. And where does the graph of sine end? One full cycle. Yeah? 2 pi. Oops, let me just fix what I did over there. Okay, so this is 0. This is 2 pi. That's pi. And what's the quarter mark in the cycle? Yeah? Pi over 2. And 3/4? 3 pi over 2. So what we're going to try to do is find a window that does pass the horizontal line test. And then if we can do that, the inverse will be a function. Yeah?
You would put it, the start of the window would be on the pi half, and the other part of it would be on 3 pi half.
All right, so let's try that and see. Should be able to drag this. That's okay. I'll just do it like that. Alright, so you said the pi over 2 to 3 pi over 2? So like about, that would be about right there?
Yeah.
Yeah, if you look at that section of the wave, it's a little bit big, but let's see if I can fix it. That section looks like it does pass the horizontal line test from pi over 2 to 3 pi over 2. There is more than one section that would pass. Does anyone see another section that passes the horizontal line test within the numbers I labeled? And I'm going to use this section just because it's the way the calculator does it. Yep.
From negative pi over 2 to pi over 2.
Yeah, so the calculator is going to use the section, right? That's pretty close. From negative pi over 2 to pi over 2. Okay, that's the section that the calculator uses. It'd probably be better if I do it like that. Right there. So if we limit sine to only thinking about that window, then the inverse will have a function. Okay, so we're going to limit the domain of sine to be between those two numbers when we start working with inverse sine. So we had a problem. The graph fails the horizontal line test. The solution: limit the domain of sine to negative pi over 2 to pi over 2. And then we can work with inverse functions because we force this to pass the horizontal line test. Okay, so let me graph inverse sine on the calculator. And let's see if we can figure out what the domain and the range is for inverse sine. Okay, this is a graph I've never shown you what inverse sine looks like. But it's going to have something to do with this negative pi over 2 to pi over 2. All right, let's type it in. So clear everything else out. We're going to put in inverse sine x. Okay, I'm in radians. So what I'm going to do is I'm going to set my window. I'm going to do zoom 7. Zoom 7 is what we call a trig zoom. And that's what inverse sine looks like. Okay, just that small little section. Now, I want to zoom in. I want to get a little bit better picture. When we talk about regular sine, what did we just say we limited the domain to? So then we could talk about inverse sine. Right, we limited the domain of the original to negative pi over 2 to pi over 2. Well, watch what happens if I set the range of the inverse to negative pi over 2 to negative pi over 2. Negative pi over 2 to pi over 2. And now let's think about the range of sine. In the section that you limited this to, what's the range in that section? Yeah?
It's 1 to negative 1.
The range in the original is negative 1 to 1. So let's set the domain of the inverse to negative 1 to 1. And you're going to get a picture now that fills the screen perfectly. That's what inverse sine looks like. So I tried to give you kind of a hint as I was doing it. You had a certain domain and range for the original. And does anybody notice what happened to that domain and range when you did the inverse?
They swapped.
They swapped, right? Y turned into X, and X turned into Y. Everything swaps when you do an inverse. Okay. So when we write down the domain and the range of inverse sine, it's the same as the domain and range of regular sine swapped. Okay, so regular sine normally has a range negative 1 to 1. In inverse sine, that's my domain, negative 1 to 1. for regular sine. We limited it to be between negative pi over 2 and pi over 2. That's purely so it would pass the horizontal line test. That limitation on the domain in the original turns into the range in the inverse. Okay. And I'll put the sketch down here so you can see what it looks like. And that's the entire graph. It does not go any further left, right, up, or down than what you see right there. That's why I showed it to you zoomed out first, and then I zoomed in. So any question on the domain and the range? All right, so let's look at inverse cosine. Well, let's draw cosine first, see if cosine passes the horizontal line test, and if it doesn't, let's find a section that does. So let's graph cosine. I'm going to do zoom 7. And does cosine pass the horizontal line test?
No.
No. So then if we try to consider inverse cosine over that entire graph, we're going to run into a problem. We're going to get something that's not a function. Our goal is to draw inverse cosine and have it be a function. So we need to make this pass the horizontal line test. So let's think about the same window we just did. Okay, I'm just going to try to draw a box. That's 2 marks wide. Let's just go. Let's move this box around. Okay, we did negative 90 to 90 before. Right there. If you focus on what's inside that box, does it pass the horizontal line test?
No.
No, it doesn't. But
No.
I found 2 spots closest to 0 that do pass the vertical line test, which are going to be 0 to pi.
Yep.
And 0 to negative pi.
Yep, so we're going to use 0 to pi. And that's how the calculator does it. So we're going to limit the domain of cosine to only be 0 to pi. That's the section we're going to consider. 0 to pi is going to be the domain restriction in the original. What do you think 0 to pi is going to become in the inverse?
It's going to become the range.
It's going to become the range, yes. 0 to pi will become the range. Now, what's the range in the original of this graph right here? Yeah?
Negative 1 to 1.
The range in the original is negative 1 to 1. In the inverse, the range is going to turn into the what? It's going to turn into the domain. Yep. So now the domain for inverse cosine is negative 1 to 1. And the restriction that we put in place on the domain, so it passed the horizontal line test, was 0 to pi. That restriction on the domain turns into the range in the inverse. Yeah.
But if you just graph the inverse of cosine, it's the range is a little higher than 0.
If you graph, let's type it in. So if you do inverse cosine, you do zoom 7. So what's happening? Well, look at the original. As you get very close to the edge of the window on either side, what's happening to the slope of the graph as you get close to the left edge or the right edge?
Kind of plateau.
And what number is it approaching?
0.
It's approaching 0. Right? The slope is approaching 0 towards the left and the right end of the box. So if slope approaches 0 in the original, what do you think the slope is approaching in the inverse? It's approaching undefined. And when we try to draw something that's undefined, remember the calculator has trouble with it. It can't draw something that's vertical. So even though we wrote the range is 0 to pi, it is 0 to pi. This goes down lower. You just can't see it. But I can show you it goes down lower. Because let's say that looks like it's about Let's see if I put a line at 0.2, if that looks like where it is. It's a little higher than that. But I can see what you say. It doesn't look like it goes to 0. Okay, so let me put it at 0.4. Okay, do you agree it looks like it stops at the red line? Now let me zoom in right near the red line. See what I mean? So it does go below that red line. And I could keep zooming in more and more, and eventually it would look like it goes.
Oh, okay.
Yeah, it's because it's getting too steep to drop. All right, so a good window to see this one, I would probably do like -2 to 2. I'm just kind of centering it in the window. And I would say, yeah, 0 to pi, that's going to be fine. Oops, not that. 0 to pi. That actually shows it, ignore that red line, but that actually shows it a little better. So now you can see it almost, it's kind of weird. It's not a smooth curve anymore. It looks like it just straightened it out.
Yeah.
Same thing up here. It was nice and smooth, and then all of a sudden it straightened out. It's smooth the whole time. Okay, now let's think about inverse tangent. Well, let's start with tangent. Okay, do zoom 7. Does the graph of tangent pass the horizontal line test? No. It fails it. So again, if a graph fails the horizontal line test, its inverse will not be a function. That's going to be a problem. You deal with graphs that are not functions, you start getting multiple answers when you plug in a single value. We don't want to get multiple answers. We want to plug in one number, we want to get one answer. We don't want to get 2 answers, or 3 answers, or 4 answers. So, we need to restrict this. And technically, it doesn't matter how you restrict it, as long as it passes the horizontal line test. The way that I'm showing you the restriction is the way everybody does it. Okay? It's the way calculators do it, and it's the restriction that we always use. So, if anybody see a restriction you could put on the domain here, maybe similar to one we did before, that would make this pass the horizontal line test.
-pi to pi.
So this is -pi right here, and this is
negative
pi.
is it -2 pi? So
So -2 pi
Oh, no.
over here.
negative pi over 2. No.
Negative
Yeah.
pi over 2.
Pi over 2 to pi over 2.
Yes.
Okay. Pi.
If you look at just what's in this box, you will find a section of tangent that passes the horizontal line test, which means now the inverse of it will be a function. Okay, what does this graph have that the other one, the other 2 graphs didn't? Yeah.
Asymptotes?
Can you be more specific?
Like on the, like it just restarts the cycle every pi cycles, if that makes sense. Like,
So I'm looking for more about the asymptotes. Not necessarily how often they occur. I'm looking for more of a type. They are vertical. Okay, the asymptotes in tangent are vertical. So what do you think is going to happen when we do inverse tangent? Yeah?
They're going to turn into horizontal isotopes at those 2 respective points.
Yeah.
So it'll go towards those 2 points, but it will never reach it.
Right.
Also, it's going to be infinity to infinity for the domain.
Right. So yeah, a lot of things you just said there that are all important. So the range here is -infinity to infinity. When we do inverse tangent, that's going to be the domain. The other thing you said is it gets very close to the pi over 2 and the -pi over 2, but it never reaches it. So instead of writing my domain with brackets, what are we going to use? Because we never reach -pi over 2 or pi over 2. Yeah.
Parentheses.
We need to use parentheses. Okay, so domain, all real numbers. Range is going to be the restriction we put on the original domain. And we said this earlier, but the two vertical asymptotes that you had, when you do a mirror image of the vertical, they turn into horizontals. All right, so let's graph inverse tangent. So domain, well, it's going to go forever left and right. So -8 to 8, whatever those numbers are from, that's probably fine. Pi over 2 is about what number?
About, I'd say the best point of that is 2. Because
Yeah.
Yeah. It's a little bit above, like, 1.5, but
Yeah.
it's below 2.
Yeah, so it's really like -1.57 to 1.57. So I'd go -2 to 2. And, bless you, if you want to put in the horizontal asymptotes, you've got one at -pi over 2 and pi over 2. So here's your graph. And the asymptote should sandwich that on the top and the bottom. There's the bottom. And there's the top. So that's what inverse tangent looks like. I just added the asymptotes. It's just the blue graph in the middle. Okay, so any questions on that? So it's a lot of things to remember. You've got domain and range for the original and for the inverse. But what I do is I just remember the original. Because if I can remember that, all I have to do is switch everything, and it becomes the inverse.
So the range is nearly the exact same between tangent and sine. The only difference is parentheses and the brackets.
Yeah, whether you include the pi over 2 or you don't include it. The tangent, you don't. Yep. All right, so we looked at some of these properties last week. This 1A, 1B, the way I'm numbering the properties, that's not really important. It's just for reference so I can talk about a certain one. So the difference between 1A and 1B, both of these are going to cancel out the function that they're next to. The inverse sine of the regular sine cancels out. And the sine of the inverse sine cancels out. And you always get back what you started with. But there's restrictions on these domains that you can plug in. You cannot just plug any number in there and it'll work. For example, plug in, just to keep it simple, let's do it in degrees. Let's plug in 100 degrees. And watch what happens. If I take the inverse sine of the regular sine of 100, I do not get back 100. I got back 80. Now, I'm saying that you're supposed to always get back the same thing you started with. And you will, under a certain condition. And it has to do with the domains that we set up. Okay? If I do the inverse sine of the sine of 50, that one worked fine. The inverse sine of the sine of -37, that one works fine. What do you think this number has to be between? And it relates to something we did in radians a little bit. Yeah.
-90.
Yeah, it has to be between -90 and 90, or -pi over 2 to pi over 2. That's why I taught you the restriction that I did. Even though I said you could do it anywhere. I did the one we did because that's what a calculator uses. Okay. How about this one? Think of inverse sine. What did we say the domain of inverse sine is? And if you can't think of the domain of the inverse, think of the range of the original. And that'll tell you what numbers you're allowed to plug in right there. Yep. Negative 1 to 1. This time, when the inverse is on the inside, if you fill in something that's not between negative 1 and 1, it won't even give you a different answer back. It won't even do it. You can't. So you've got to pick a number between negative 1 and 1. And if you take the sign of the inverse sign of that number, you will always get back what you started with. Now, we used this last week. When you had something like this. When we were solving right triangles. And I said, how do you get rid of sine? Well, you use the inverse sign. So we said, take the inverse sign of both sides. And when we did that, all I said to you was, these two things just cancel out. How come I didn't have to tell you this restriction last week? It wasn't important that you knew it for the kind of problems we were doing. What kind of problems were we doing? Yeah. We were working with triangles. What kind of triangle?
Right.
We were always working with right triangles. And you were always solving for like what was right there. What do you know about this angle? Or this one at the top? All the time. Yeah.
It's always smaller than 90.
It's always smaller than 90. So even though taking the inverse sign only works when the angle is smaller than 90, the angle was always smaller than 90. So it was going to work all the time. That's why I never told you this. You didn't need to know. Okay. All right, let's look at the next step. Okay. The inverse cosine of the regular cosine. Those two things will cancel out as long as x is between two values. What did we limit the domain of cosine to? This was so it would pass the horizontal line test. Yep.
It has to be between 0 degrees and 180 degrees, which is 0 and pi.
Yes. Has to be between 0 and pi. Or 0 degrees and 180. Yep. All right, now when you have the inverse cosine on the inside, this is the kind of problem that we did last week. Oh no, the top one was the kind of one we did last week. And when you're solving a triangle, you are guaranteed that your angle is always smaller than 180. In fact, you're guaranteed it's always smaller than 90 in a right triangle. How about here? What do you think the restriction on x is when the inverse is on the inside? Think about the domain of inverse cosine. Sophia? Yep. The domain of the inverse is the same as the range of the original, negative 1 to 1. Which one of these, 2a or 2b, is the one that if you plug in a number outside what you're supposed to, you won't even get an answer back. You'll get an error. Is it 2a or 2b that gives you an error? 2b, yeah. If you plug in a number that's not between negative 1 and 1, you won't even get an answer. In 2a, if you plug in a number that's not between 0 and pi, you'll get an answer, but it won't be what you started. All right, let's look at the last one. Inverse tangent will cancel out regular tangent as long as that angle is between what two numbers? Yeah?
It has to be between the 90 degrees, negative 90 degrees and 90 degrees, but it can't equal it either.
Right. So it has to be strictly between. It does not have the equal to. And again, why wasn't this important last week? Because your angle was always less than 90 in a right triangle. It has to be. So it wasn't important. Okay, how about the bottom? The tangent of the inverse tangent will cancel each other out as long as x is between what two numbers? Yeah, Sophia? It's all real numbers, yeah. So if you see a problem like tangent of inverse tangent, you don't even need to think. Whatever they put in the parentheses after it, they're always going to get the same thing back. It's all real numbers. I just made up 545. Okay, so any questions on when inverse trig and regular trig cancel each other out based on those domains? Okay. All right, so we've done this a lot. Transformations. Exactly the same as all the transformations we've done before. Okay, so we'll go through them like we do. Okay, I'm not going to write it down. If you're not sure, you can write them. But let's start with A. What kind of transformation would A be? Yep. Horizontal shift. Yep. If A is positive, it goes to the left, negative, right. Okay. Let's do D. What kind of transformation is D? Yep. Vertical shift. I just want to do the shifts first. What if D is positive? Goes up, negative,
Down.
goes down. So there's your shifts. Now let's do the other ones. B. What kind of transformation is that?
Horizontal stretch and compression.
Yep, horizontal stretch or compression. If B is a big number, what does it cause the graph to do? Compress. Small number, stretch. What kind of transformation is C? Yep.
Vertical stretch and compression.
Vertical stretch or compression. If C is a big number, like say 20, what happens? Stretch. What if C is a small number? It compresses. And if B or C are negative numbers, what does that do? That's a reflection. C is what kind of reflection? Yep. So C would be a vertical reflection, which would mean it would flip up to down. So that's over the x-axis. B is a horizontal reflection, which means it would flip left to right. That's over the y-axis. Okay, so any questions on what the transformations do? Okay, which out of the A, the B, the C, and the D, which ones would affect the domain? Yep.
The ones that would affect the domain are only going to be A and D. B and C are not going to affect the domain. It'll just change what the graph looks like. Well, B is actually... I'm pretty sure actually C is also going to affect the graph. But
They all affect something. Two of them affect the domain and two of them affect the range.
yeah.
So they all will do something. But which two would affect the domain? Yeah?
A and B.
A and B. Domain is measuring the horizontal. A and B are the horizontals. C and D would affect the vertical. So how do you find the new domain and range if you had something like this? Okay, an inverse sine function, but you've done some stretching and shifting. All right, first step. The way you're going to find the new domain, there's a couple ways you can do it, but we're going to create a compound inequality. The idea is we're going to put the argument in the middle, because that's what affects the domain. So put that in the middle, and then put the original domain on the left and the right. And then you're going to solve it. So argument in the middle might be something like 3x. Original domain on the left and on the right. And then you solve for x. So in this case, it would be negative a third to a third. So that's the domain. And for the range, there's two things you have to take into account. What do you think you would do first to find the new range? Would you take into account the stretch or the shift?
Stretch.
Yes, because the stretch is C and the shift is D. So C, then D. All right, so let's pick some simple numbers. Let's say you had a range that was originally, I'm just going to make up something, -3 to 3. If you stretch that by a factor of 2, what would happen to it? If it was -3 to 3, stretch it by 2. Yeah?
-6 to 6.
It would become -6 to 6. Now, let's say you took that and then moved it up 4. What would happen to -6 to 6 if it went up 4? This is the process of how you find the range. Yep.
-2 to 10.
-2 to 10. Yep. So that's exactly how you find the new range. Take into account the stretch, and then take into account any shifting. Okay. In that order. Okay. Any question on that? All right, let's try it. So it says find the domain and the range of the following. Okay, y equals inverse sine 2x. How many transformations in this one? One. So that means something isn't affected at all. Let's get that one done first. What's not going to change here? Yeah.
The range.
The range. Right? This is a horizontal compression by a factor of 2. It's going to squish the domain. It's not going to do anything to the range. So what is the range of the inverse sine? And remember, if you can't remember the range of the inverse, think of the domain of the original. Yep. Including or not including it? Yes, including it. Yeah, so the range is unaffected. Now, domain. Create a compound inequality. Put the argument in the middle. And put the original domain on each side. What's the original domain for inverse sine? Remember, if you can't remember the domain of the inverse, think of how high and low the original goes. Yeah? -1 to 1. And now solve for x, and that's your new domain. How do we get x by itself here? Yeah?
Divide by 2.
Divide by 2. So as an inequality, your new domain is -1/2 to 1/2. How about as an interval? How would I write my domain? Well, Xavier, do you know how we write the domain?
This one? So for the domain of the also x values, so wouldn't that just be, since you're doing the negative sign of it, would that be like positivity and negativity since you're like turning it, or is it like,
No, not the only one that has something to do with infinity is tan, inverse tan.
I mean, because before you did inverse sine, the domain was -1, 1. But that was just for the regular sine, sine -1 thing. So, I don't know.
Negative and 2 1/2, -1/2, and then
So does inverse sine have a domain that had infinity or negative infinity originally?
No. It was
No.
1, -1.
Then it's not going to have anything to do with infinity when you stretch or compress it. If it didn't have infinity to start with it's not going to have infinity after this. Yeah.
All you're going to do is have negative 1/2, comma 1/2 brackets on both sides.
So -1/2 to 1/2. So I set up above, that's the inequality, but I wanted it as an interval. Okay. And that's your new domain, range stayed the same.
I think I was focused on tangent. I think I
Yeah, we'll do one with tangent.
because I'm just tangent's the one that has an infinity thing. Sorry.
All right. How about this one? Inverse sine 1/3 x.
3.
What- So what is the 1/3 doing? Let's start with that.
It's like going to stretch it out because when you do like if you did like 5x, it would make it thinner. If you do 1 million and 1/1,000,000,000, it would stretch it out and make it wider. So therefore, since it's 1/3, it's going to make it wider. It's going to stretch it and not compress it.
Yeah, this is going to stretch it 3 times as much.
Yeah. So that means it's going to go -3x and -3 +3 because of the domain.
Right. So the original domain was -1 to 1. You're stretching it by a factor of 3. I don't think we really need to set up an inequality to solve that. If it gets a little more complicated, we might. But hopefully we can just understand it's just stretching by 3. So take -1 to 1 and triple it. Okay. How about the range? Yeah. Say it again. -π/2 to π/2. There is no change to the range. Hey, any question on that one? So let's try this one. I know we're doing a lot with inverse sine. I think I got one that's not inverse sine though. Coming up. Okay. So inverse sine of x plus 2. Right. What's the plus 2 going to do? Kind of transformation, yeah?
You shift it up to.
It's going to shift it up 2. Shifting something up is going to affect the what?
Range.
It's going to affect the range. So this time there's no change to the, there is no change to the domain. So what's my domain of inverse sine? No change to it. Yeah. -1 to 1. Okay. Now, what was my original range for inverse sine? Yeah.
The original range is -π/2 to π/2.
-π/2 to π/2, and we're shifting that up 2. There's not really a nice way to write that, other than just basically -π/2 plus 2 to π/2 plus 2. And you could find a common denominator and put it together. So you can make it pi plus 4/2. That's any question on that? All right, let's try this one. 5 inverse cosine x. Okay, what's the 5 doing?
Compress it.
Stretch, which way? Vertically. Stretching vertically is going to affect what? Yep.
It's going to affect the range.
It's going to
So
affect the range.
Domain is going to be the same as always for this, which is going to be -1 to 1.
Yep. So inverse cosine has a domain of -1 to 1. Yep. The domain for inverse sine and inverse cosine are the same. Now be careful, we're doing inverse cosine. What's my range for inverse cosine? Yeah, it's okay. 0 to pi. If you stretch that 5 times as much, what would it be? 0 to 5 pi. So with 0 to pi, it stretches 5 times as much. Any question on the domain or range for that? Okay. All right, let's try this one. 3 inverse tangent 2x. What's the domain? Yep.
So normally the inverse tangent is negative infinity to infinity, but since we're doing like if it was that before, like when negative 1 it would change, but I think it's still going to be negative infinity because you can't have negative 2 infinity. I mean negative a half infinity, positive a half infinity. So I think it's just going to stay the same.
So the domain is unaffected. You cannot change the domain of an inverse tangent function, no matter what you do. It's always negative infinity to infinity. The range you can. Okay. Which number here is affecting the range? The 3 or the 2? Yeah, it's the 3. It's a vertical stretch by 3. What is the original range of inverse tangent? If you can't remember the range of the inverse, think of the domain of the original, what we limited it to. Yep. So negative pi over 2 to pi over 2. Can you tell me a little bit more? Not including. We're going to stretch that by 3. So what's going to be my new range? Yeah.
It would be negative 3 pi over 2 with 3 pi over 2 with parentheses instead of brackets on the side.
If you put brackets on that, it would be marked wrong. You cannot include those because those are now horizontal asymptotes. Okay. It will never reach those values. Okay, any questions on that? Let's try another one, kind of similar. I'm not asking for, am I asking for the domain and range? Nope. I just want you to tell me the transformations. Okay, any thoughts about that equation? Y equals inverse sine, 3 inverse sine, and then in parentheses 1/4 x plus 8, and then minus 5 on the end. Yep.
Because there's 2 sets of parentheses there, we're going to have to distribute the 1/4 into the x and the 8, which will bring it to 1/4 x plus 2.
Okay, so let's do that first so we can get this more in what I would call like standard form. So we can see the A, the B, the C, and the D. C and the D were okay. We could tell what those were, but the A and the B, not as much till we distribute it. So 1/4 x plus 2 minus 5. That's what we want to look at. Okay, how many transformations are happening in that problem? Yep, we've got 4. So it says identify the transformations and then find a complete graph. Well, we can find a complete graph after we do all the transformations. Okay. What's the first transformation that's going to happen? Like
2 to the left.
Yeah, we're going to shift 2 to the left. All right. Second one. Yeah. Yeah. This 1/4 is going to cause the graph to get bigger, so it's really going to stretch by 4. Yep. So horizontal stretch by 4. Okay. Next thing that's going to happen.
Vertical stretch by factor of 3.
A vertical stretch by factor of 3. And the last transformation.
Down 5.
Yep, shift down 5. Now, they didn't say to get the domain and range, but if you're going to find a window, you kind of need to know where to look. So, you kind of need them. What's the domain of inverse sine? Regular domain of inverse sine. Yep.
-1, 1.
Okay, so let's start with that. So the domain originally is -1 to 1. And what's the range of inverse sine? Well, Max,
What is it?
what's the range?
The range?
Of just inverse sine?
Inverse of just like the regular range? Is it negative pi over 2 to pi over 2?
Now let's do the transformations and see what happens. Okay, I'll start with the domain. So at the domain, it's going to go left 2 and then stretch by 4. Where would that domain go if it went left 2? Yeah.
-3 and -1.
So -3, -1. And now stretch it by 4. What would happen to it?
-12 and
So -12 to -4. So that gives me an idea of my x min max. Now let's do the y min max. Stretch by 3. So it's going to go So it's going to go -3 pi over 2 to 3 pi over 2. And what's the last thing that happens to the range?
Down 5.
Down 5. So -3 pi over 2
-5.
minus 5, comma, 3 pi over 2
-5.
minus 5. Okay, so let's see if we can get a good window. What would be a good x min and x max? I'd rather not have the graph like right on the edge of the screen. Yeah,
So I guess -13, -5.
yeah, we could go -13, -5. And now let's figure out what negative
-5.
yeah, -5, thanks. Let's figure out what -3 pi over 2 is. I'm just typing this in so it'll give me the decimal real quick. So it's -4.71. So what would be a good number if you take -4.71 and minus 5 from it?
-10.
Yeah, we'll do -10. And what about 4.71 minus 5? Yeah. So that should be a perfect window once we type it in. Okay, what was it again? You could type in either one. I think I'm going to do the one where it's already distributed, so it's less parentheses. 3 inverse sine. And so I don't have to do parentheses with the fraction. I'm going to do 0.25x plus 2 minus 5. Let's see. Okay, so we're not seeing your graph. How come? Yeah, that's not what it should look like. Anybody see something we need to fix?
you mind going to window?
Window? Yeah, I think our window is okay. Yeah. You need to be in radians. This 3 pi over 2 number, that's radians. That is not degrees. So if you get a graph that doesn't look right, check your mode. Put it in radians. Let's see what we get now. Perfect. That's what our graph should look like. I don't know if we need to go a little further. Oh, well, -4. We should have gone a little bigger than -4. We went smaller. So this should have been -3. That's why it was cut off. Because if you set the window the way we did, there should be white space around the whole graph. Exactly like that. So when I didn't see that white space in the upper right, I knew something was a little bit off. Okay, so there's your window. Any questions on that one? Okay, so I didn't have to find the domain and range, but it really helps you to set your window. Okay, we do everything they wanted, identify, and find a complete graph. Okay. All right, and the last thing is kind of a review of what we've already done. How do you type inverse trig in to evaluate something on the calculator? All right. So, if I want to type that in, what do I have to press to do inverse sine of 0.5?
You'd hit second sign and then 0.5.
Yeah. Now, should I be in degrees or should I be in radians?
You should be in radians because there isn't a degrees mark there on the 0.5, so it should be in radians.
When you do, I think when you do the sign of like the numbers you're going to find degrees, like I think like when you do, like if you were doing sign of like 0.444 or something, you somehow find the degrees of it. It's like what the, it's like the output, like you combine the sign and everything.
I actually think it might be in degrees. Because if you have the calculator in degrees mode and do that, it'll get you 30. And the other one will get you 0.5 to something.
Yeah, so
it just goes on.
Remember, this is not an angle. When you plug in a number to an inverse trig function, you are solving for an angle. So you can be in any mode you want. It depends on what they want the answer in. This one doesn't say. So if you want the answer in degrees, well, then put your calculator in degrees. If you want it in radians, put it in radians. But if I ask you for an exact answer, and you tell me 0.524, that's going to get marked wrong. That's not an exact answer. How did I always recommend you do it? If I want you to get an exact answer. Yeah?
Find the degrees, do it times pi over 180, and have like the most reduced fraction you can as the answer.
Yep, so do it in degrees first. And if I tell you to get an exact answer, then it will come out nice in degrees. Always. So in degrees, the answer is 30. What is that in radians? I mean, I know it's 0.5235. I don't want the decimal. I want a fraction. Yep.
Pi divided by 6.
Pi divided by 6. I mean, if you recognize 0.52359877 as pi over 6, great. But you might not always recognize this decimal. So do it in degrees first. Okay, so either answer is correct. Okay, let's try this one. Now I will tell you, negative inverse sine of negative 0.7, it's not going to come out nice no matter how you do it. So let's do it in degrees and then we'll do it in radians just to practice both. Okay, so inverse. inverse sine of negative 0.7.
Negative 44.42704.
So you got an answer.
Yes, I have it in degrees.
Okay. What does this number have to be between to make sure we even get an answer?
Parentheses.
No.
Well, there's a limit on the number. Yep. It had to be between negative 1 to 1, and it is. So you will get an answer. It's about negative 44.43. Since it doesn't come out nice in degrees or radians, I'm just going to do degrees. What's going to happen here? Kind of set you up for this with the question I just asked. Yeah.
This is going.
Well, no, yeah, sorry.
We're not going to get an answer because it's not within the, like it's over 1.
Yeah, this is outside the domain of what you're allowed to use for inverse sine. So if you type that in, you're going to get an error. It's not going to work. So just write down no solution. Okay, and that's the first part of 7.2. It's all about domain and range and inverse trig. Let me double check that. So 1 through 9 is all about finding domain and range and listing transformations. So those are pretty straightforward. What's another way that you can write this, just in case you see it in the homework tonight? There's another notation for that. Yeah?
Arc sine.
Arc sine. Means the same thing. Okay, 13 through 20, that's using a calculator. You just have to plug them all in, so those are pretty quick. 22 to 24, it's more of the same thing. Yeah, so that's fine.
Doesn't sine negative 1 equal 1 over sine?